says passing a test by guessing. Okay, it says a true-false test has 40 questions. Okay, and it says passing grade is 60% or more. 60% or more correct is pass. Alright, so it says what is the probability that a person will guess correctly on one true-false question? Okay, so if you're going to guess, just randomly guess on true-false, the probability of guessing correctly is 50%. 50% for one question. Okay, and it says what is the probability that a person will guess incorrectly on one question? Alright, so on one question, the probability of guessing incorrectly is 50%. On a question. So you've got 50-50 chance of guessing it right or wrong. It says find the approximate probability that a person who is just guessing will pass the test. Okay? So here, we want to know what's the probability that we're going to get 60% or more. So let's check conditions. Alright, so independent and random. So this, we're not dealing with a random sample anymore, okay? But every question that is, if this person is truly just randomly guessing 50-50, basically just flipping a coin whether to put down true or false, then he's got a 50% chance. Each question is truly independent of each other. Okay, so if the person just flips a coin, and if it lands heads, he puts true, and if it lands tails, he puts false, or whatever he chooses. Okay, then the questions are independent of each other. All right, we want to check, is this a large enough sample? So in this case, we do n times p. Is that greater than 10? And n times 1 minus p, is that greater than 10? So here, n is 40 and p is 0.5. That gives me 20. And then n times 1 minus p is 40 times 0.5. Also gives me 20. Both of them are bigger than 10, so our sample is large enough. Okay. And large population, so we're not dealing with a sample, so we don't really have to worry about this, but could there potentially be more than 40 questions, 400 questions? Sure. So there's technically an infinite number of questions that we could have. So we've got that. So now, anytime a student guesses on all 40 questions for a true-false exam, the p-hats follow a normal model. Okay, p-hat being the proportion that he gets right. Okay, so the p-hat proportion, correct. Okay, we expect about 50% to be right, but sometimes he'll be lucky and get more than 50%. Sometimes he'll be unlucky and get less than 50%. Alright, so the mean of this normal model is going to be 50%. We expect 50% to be answered correctly, and the standard deviation is our standard error, which is going to be the square root of p times 1 minus p over n, square root of 0.5 times 0.5 divided by 40, I get a square root of that, and I get 0.079. So my standard error is 0.079. And we want to know, so anytime we just randomly guess on all 40 questions, my p-hat, we're expecting something around 50% correct answers. So 50% goes in our center, our mean goes in our center, and we're hoping to get 60% or more. And we want to know what is the probability of ending up 60% or more. So we get a z-score, 0.60 minus 0.50 divided by 0.079. get a z-score of basically 1.27. And now I look this up in my my table. 1.27 gives me an area. 1.27 gives me an area of 0.8980. So to the left I have 0.8980. So the area to the right, so from the z table, I do 1 minus 0.8980. This gives me a probability of being greater than 1.27. This is going to be 0.1020. Alright, so what's the probability of getting 60% or more? By random guessing. That answer is 0.1020. Got about a 10% chance of passing just by random guessing. And then part D says, if a similar test were given with multiple choice questions with 4 choices, would the approximate probability of passing the test by guessing be higher or lower than the approximate probability of passing by true false? Alright, so the answer there is going to be much lower. Because in this case, if it's 1 out of 4 answers are correct, the p is 0.25, which means our mean, if we created a new model, the mean is going to be 0.25. Alright, and I haven't bothered calculating the standard error out, but the distance from 0.25 to 0.60 is going to be much, much farther now. Okay, so 0.60 was only like basically 10 points away from 0.50, so it was only 1.27 standard deviations away. 0.60 is now 35 points away, 35% away from what we're expecting. When somebody just guesses by random chance on a multiple choice test, we're expecting that person to only get 25% of the questions right. And now to pass, this person needs to get 60% of the questions right. And so that's going to be much, much harder to do. And so the probability of that happening is much, much lower.